class. Did you understand your lesson last week? About getting the nth term of the general formula of an arithmetic sequence, getting the value of an indicated terms of an arithmetic sequence, or getting the sum or the series of an arithmetic sequence, or inserting means between the given two terms. So I'm really hoping that you mastered already those ideas. Anyway, this week, you're going to study about geometric sequence and series. So my dear student, when we say geometric sequence, it is a sequence in the form of a sub 1, a sub 1 times r, a sub 1 times r raised to 2, a sub 1 times r raised to 3, and so on and so forth. Where a sub 1 referring to the first term of a geometric sequence, and r is referring to the common ratio. So this means the given sequence is said to be geometric if and only if it has a common ratio. Now I will show you some example of a sequence, then let's find out if it has a common ratio. Let's say we have 2, 4, 8, 16, 32. So again, we're going to determine if this given sequence is a geometric. A given sequence is said to be geometric if it has a common ratio. So to obtain the common ratio, we simply divide all the terms from the last to the first. So let's divide. 32 divided by 16 will give us 2. 16 divided by 8 will also give us 2. 8 divided by 4 will also give us 2. And 4 divided by 2 also has 2. So therefore, we can say that this sequence is a geometric sequence. Another, let's say we have 3, 6, 9, 12, 15. So let's divide. 15 divided by 12 will give us 5 over 4. Am I right? 12 divided by 9 will give us 4 over 3. And 9 divided by 6 will give us 3 over 2. And 6 divided by 3 will give us 2. So, from this second example, we have no common ratio. Therefore, this given sequence is not a geometric sequence. Simple as that. Now, let's come to the general term of the geometric sequence. The nth term of the general formula of the geometric sequence is denoted by a sub n is equal to a sub 1 times r raised to n minus 1. This formula is used in dealing with the geometric sequences. Without further ado, let's study this given example. Let's say we have 3, 6, 12, 24, and 48. Our task is to find the common ratio of this given sequence and then the general term or the general formula of this given sequence. So, again, in order to obtain the common ratio of this given sequence, we always divide all the terms from last to first. So we divide. 48 divided by 24 will give us 2. 24 divided by 12 will also give us 2. 12 divided by 6 will also give us 2. And 6 divided by 3, the quotient is 2. So therefore, our common ratio is simply 2. Simple as that. But how about in getting the general term or the general formula of this given sequence? So again, in order to find the general formula, we simply use the format or we simply follow the given format, which is a sub 1 times r raised to n minus 1. So we simply substitute the value of the first term and then the common ratio. So our first term is 3. So we have here 3. And our common ratio is simply 2. So we have to multiply it by 2. Then we simply copy raised to n minus 1. So therefore, this is the general term or the general formula of this given sequence. Let's try another example. Let's say we have 5, 15, 45, and 135. So again, our task is to find the value of the common ratio and then the general term of this given sequence, or the formula of this sequence. So, let's divide 35 divided by 45. I mean 135 divided by 45 will give us 3. 45 divided by 15 will also give us 3. And 15 divided by 5 will also give us 3. So therefore, our common ratio is simply 3. Then, for the general term, we simply use the format which is a sub 1 times r raised to n minus 1. So we substitute first the first data, or the first term, which is 5. Then we multiply it to the common ratio, which is 3. Then we copy n minus 1. This is the formula of this sequence. So it is very easy to find the n term, or the formula of the sequence, as well as the common ratio, if our given is in this format. What if the given terms are non-consecutive terms, just like this one? Let's say we have a sub 5 is equal to 32, and our a sub 8 is 256. Our task is to find first the common ratio, the value of the first data of this sequence, the formula of this sequence, then the value in the 10th term. So in dealing with this example, we must derive two equations first, meaning equation for this a sub 5 and equation for this a sub 8. So this time, your first equation must have a highest given terms. So from this given terms, our highest is a. So we must take this first. So we have here a sub 8 is equal to a sub 1 times r raised to n minus 1. Then to be followed by the other given terms, which is a sub 5. So here a sub 5 equals to a sub 1 times r raised to n minus 1. Then next, we substitute the values for the given terms. So we have here our a sub 8 is 256. So we substitute here 256. Then our a sub 5 is 32. So we substitute here 32. Then we don't have the value for the a sub 1 as well as for the value of r. But for our n, remember n referring to the number of terms. So therefore, our 256 is for the 8th term. So we can substitute here 8. Then for the other, our n here is 5. So we substitute here 5. Then we simply divide these two equations. 256 divided by 32 will give us 8. We divide this one. Then a sub 1 divided by a sub 1 is simply 1, am I right? Any number or any variable divided by itself, the quotient is always 1. So we have to cancel this 1. Then, we simply copy the common variable r. This is because we have to subtract the exponent. 8 minus 1 will give us here 7. And 5 minus 1 will give us 4. So this is the final exponent. So now, by using the laws of exponent power by quotient, we simply subtract the exponent. So 7 minus 4 will give us 3. Then, the exponent of our variable r is 3, so therefore we can use the cube root. I use cube root in order to cancel this exponent 3. So since we apply cube root on the right side, automatically we have to apply also cube root on the left side of the equation. So we have here, cancel this 1, the remaining is simply r. Then the cube root of 8 is simply 2. So therefore, the common ratio of this given sequence is 2. Now, our problem is the first data, or the a sub 1. So, in order to find the first term, or the first data, we can use either of these two equations. You can use the numerator or the denominator. But I prefer this denominator. Okay, so I use this one in order to find the value of a sub 1. So we have here 32 equals a sub 1 times r. The exponent of r is 4. Then, we substitute the value of r because we have here the common ratio 2. So we substitute here 2. So copy 32, a sub 1. Then, our 2 is referring to the r. Then, copy the exponent 4. Then, 2 raised to 4, meaning you have to multiply 2 by itself 4 times. So, 2 times 2 is 4 times 2 is 8 times 2 is 16. So, therefore, a sub 1 times 16. Then, copy this 32. So, we have to cancel 16. So, we simply divide all the terms by 16. We cancel this one. So, the remaining on the right side is simply a sub 1 for the first term. Then, 32 divided by 16 will give us 2. So, therefore, the first term or the first data of this given sequence is 2. Now, we have the value of the common ratio as well as the value for the first term. So, we can now able to find the formula of this given sequence. So, by using the format of the general term, we have a sub n is equal to a sub 1 times r raised to n minus 1. So, we simply substitute our a sub 1 is 2 and our r is simply 2. Then, copy this one n minus 1. So, therefore, our formula is 2 times 2 raised to n minus 1. Then, we can find the value in the 10th term by using this formula. So, we have here a sub 10. We are dealing with the 10th term. So, our a sub 1 times r raised to n minus 1. Our a sub 1 is 2. Our r is 2. And our n, referring to the 10th term, so we have here 10 minus 1. Then, we simply copy this first, then this one, and 10 minus 1 will give us 9. And then, so we have to multiply 2 by itself 9 times. So we have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256, times 2 is 512. Then 512 times 2 is 1024. So we have here 1024. Therefore, the value in the 10th term is 1024. So I hope this is clear. Another, let's say we have insert 4 geometric means between 1/2 and 1/2048. So we have to analyze first the problem. It says you have to insert 4 geometric means between these given two terms. So our first term is 1/2 and we have to insert 4 terms. Then to be followed by the last given, which is 1/2048. So we have to determine first the common ratio in order to find the values in these missing terms. So we can obtain the common ratio by making the formula based on this given last term. So we have here 1/2048, our given last term. Then the formula, the general formula is a sub 1 times r raised to n minus 1. So, we simply substitute. Our a sub 1 is 1/2. We have here 1/2. Here 1/2. Then we don't have yet the value for r, so we copy r. Then our n is referred to the number of terms. This value is for the 6th term. Am I right? I mean 1, 2, 3, 4, 5, 6. So therefore, our n is 6 minus 1. We copy this one. Then, we simply evaluate this one first. So, copy again. And copy also 1/2. Then r. Then 6 minus 1 will give us 5. Then, we have to cancel 1/2 since 1/2 is the coefficient of the variable r. Our target is this common ratio or this r. So, we have to divide all the terms by the coefficient of r, which is 1/2. And this is cancelled. And r raised to 5. Then, if you observe the terms on the left side of the equation, it looks like a complex fraction. So, to avoid that, we rewrite this fraction bar into a division symbol. So, this is our numerator. Am I right? So, we have here 1 over 2048. And this fraction bar, we change it into division symbol. And this is our denominator. So, we copy 1/2. So, I think you are getting the idea. So, in dividing fraction, we have two ways. You can use either the cross multiplication or the reciprocal process. So, this time, I take the cross multiplication. So, I will continue the process in this portion. So, I copy first 1 over 2048 divided by 1/2 equals raised over 5. So, again, I use the cross multiplication process. So, in cross multiplying, we have to take first the numerator. So, 1 times 2, that is 2. The product is the numerator since 1 is in the numerator. Then 2048 times 1 is simply 2048. Then we copy the terms on the right side. Then we have to lowest term this 1. So what is the common factor between 2 and 2048? That is 2. So that means we have to divide these terms by 2. So 2 divided by 2 will give us 1. And 2040 divided by 2 will give us 1024. So, copy this one. Then, observe our exponent for the variable r is 5. So, we can use the fifth root. I use the fifth root in order to cancel this 5. So, since we apply here fifth root, automatically we apply fifth root also onto the other side. So, cancel this one. We have here simply r. Then, the fifth root of 1 is simply 1. Am I right? Then, fifth root of 1024 is 4. So, therefore, our common ratio is 1/4. So, again, our common ratio is 1/4. Am I right? So, again, we have to multiply 1/4 to the first term in order to obtain the second term. And multiply again by 1/4 to obtain the next term. So on and so forth. So we have here our first term is 1/2. We have to multiply it by 1/4 to get the second term. So we have here a sub 2, meaning our second term. So 1 times 1 is simply 1. Am I right? In multiplying fractions, we simply multiply numerator to numerator, denominator to denominator. Again, in multiplying fractions, we simply multiply numerator to numerator, denominator to denominator. So 1 times 1 will give us 1, 2 times 4 will give us 8. So therefore, our second term is 1/8. Then, our value for the second term, we have to multiply this also by 1/4 in order to obtain the next term. So, for a sub 3, we have here 1/8 times 1/4. So 1 times 1 will give us 1, 8 times 4 will give us 32. So our a sub 3 is 1/32. Then, to find the next term, we simply again multiply this value to the common ratio 1/4. So we have here a sub 4, this 1/32, multiply it by 1/4. Then 1 times 1 will give us 1. Then 32 times 4 will give us 128. So therefore, we have here 1/128. Then we simply multiply this also by 1/4. So we have here, multiply it by 1/4. 1 times 1 will give us 1. And 128 times 4 will give us 512. And if we multiply this by 1/4, we get this value. So, I hope this is clear. Now, let's look at the geometric settings. So, in getting the sum of the given general sequence, we can use the formula S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. So, again, this formula is used when we are going to find the sum or the total of the given geometric sequence. Without further ado, let's study this given example. Let's say we have 4, 12, 36, 108. Then we're going to find the sum of the first 5 terms of this given sequence. So again, we are not dealing with the sum or the total, so we can use the formula of the series, which is in the form of S sub n is equal to A sub 1 times the quantity of 1 minus R raised to n all over 1 minus R. So our first data is 4, so we substitute here 4. Then this is constant, so we have to copy minus. Then our R is the common ratio, so we have to divide first this given terms from last to first in order to obtain the common ratio. So 208 divided by 36 will give us 3, 36 divided by 12 will also give us 3, and 12 divided by 4 will also give us 3. So therefore, our R or the common ratio is 3. So we substitute here 3, then raised to n. Our n is referring to the number of terms. So now we are dealing with the first 5 terms. So automatic our n is 5. So we have here 3 raised to 5 all over 1 minus 3. 3 is the common ratio. Okay, then now we have to copy again 4 and 1. Then 3 raised to 5 is simply 243. So we have here 243 all over 1 minus 2 was negative 2. Then copy again 4. 1 minus 243 will give us negative 242 divided by negative 2. Then we simply divide this one. Copy 4. Negative 242 divided by 2 will give us positive 101. Then we simply multiply. 101 times 4 will give us 484. Therefore, this is the sum of the first 5 terms of this given sequence. So we have S sub 5. This is our answer. So if you have some clarification, please don't hesitate to chat. Before I end this video, I want you to solve the given exercises on your video. And of course, the last but not the least, don't forget to answer your weekly test. So again, I guess this is now the end. So goodbye class, and keep safe and God bless.